Imagine that you have some function, no matter which function, absolutely any function. For example, what if you have some function which was a piglet? So you take a very nice, cute piglet, put into this function, and as the result, you will receive the dressed piglet in a costume. And again, you put piglets in this function, and it returned to you dressed piglets. And you say, okay, this is very nice function, it dressed to me piglets. But at some point you take one of the piglets and put into this function, and it it returns to you absolutely the same piglet, not dressed, as you put into this function, as you receive the undressed piglet. You think, what's wrong with this function? Maybe it's broken or something wrong, but not. That's okay. Actually, this type of the problem, this piglet. And this type of the piglet, so this, in other words, this type of argument is called the fixed point for this function. This means that for this function, if you have some argument which if this function takes, and it will return to you absolutely the same argument without no modifications. Fixed point have some geometric interpretation, and it is very easy to see. For example, here you have this blue function, and to find the fixed point of this function you need to find the intersection between this function, blue function, and this line function, y equal x, and as you can see here we have three fixed points, and at the in general it is the function may not have the fixed points. For example, here if you look at this Cartesian area, Cartesian coordinates, and you imagine some function, for example, if it starts somewhere here and goes like this, then it has no intersections with this line, and that's mean that there is no fixed point. Or if you draw the parallel line for this line, as you can see that there is no intersection of these lines, and that means that there is no fixed points in this case. Some of the fixed points, if they exist for function, can be found with the iteration, with the iterated function application. For example, if we take some point x, and apply at the next element of the system or the sequence, we take this x and apply to f, and so on. This sequence can converge to some fixed point. Let's demonstrate this notion of iteration with Haskell. So I will start Haskell here, and what we need for this? We need a first iteration function. Let's look at it, type signature. So this function take some function from a to a and some initial point, and we will receive the list of a's. So actually we're interested in this list of a's. Okay. Now, what we want? For example, we can take a square root function. It has the following type signature. This means that it can be used here in the iteration function. Now I want to define some iterator function which can be constructed from iterate function and square root function. So I just do some partial application here, and as you can see, what we have the function of this type signature. This function takes some floating number a and produces to me a list of a's. So actually this is our iteration process. And what now we can do? We can, for example, run this iteration function for some number, and if I run it, it will do this iteration in an infinite way. Of course, I don't want to do this. I want to take some steps, and I take, for example, 5 steps. For example, we can start from 1 step, okay? And as you can see, it's just nothing happens, so there is no any application. I apply 4 to this function, and it received to me 4 because there is no actual application of the square root. But now, if I take 2 steps, it has the true application. Now I can take 3 steps, and you can see we start to move to our fixed point. And I guess you understand what is a fixed point of the square root. So again, for example, let's take 10 steps. Okay, you can see that the getting closer and closer to some number 1, because this is the fixed point. And if you look at the 100 steps, they can see that they go closer, and at some point they converge into this fixed point.